Alright guys, welcome to part 2 of the video where we're going to cover pages 3 and 4. If you're not looking for anything that's on pages 3 and 4, please refer to the other videos. Just a friendly reminder, please try these on your own first. Then come and look and see what you did, okay? You get a lot more out of finding things out from your mistakes than simply copying what I do. So we're on number 7 where we have k of x. And I'm going to start by rewriting simply because this is a double chain rule. So the innermost function is 5x minus 2. Then we have that to the 1/2. Then we have the natural log of that. So that's 3 functions. So a function inside a function inside of a function. So to begin, you're going to start with the derivative of the innermost function, which we already said is 5x minus 2. So the derivative is 5. From there, we're moving to the next function. So we've got 1/2, leave the inside alone, subtract 1, so the negative 1/2. And then times the derivative of the outermost function. The derivative of natural log is 1 over whatever is in there. Okay. And then we clean up. So it appears that only the 5 stays on top. Then we have 5x minus 2 to the 1/2 on the bottom, as well as just a 5x minus 2. There's also a 2 down here. Good. Then, since these both have the same base, we can add exponents. So technically this is a 1. So a 1/2 plus a 1 is 3/2. And we're not going to have any rational exponents. So you're going to rewrite that as the square root of 5x minus 2 cubed. For number 8, this is a product rule. Okay. Not too bad, except for in here we're definitely going to have a chain rule because of the 4. So f prime of x is the first times, like I mentioned, the derivative of the second is going to have that extra 4 there because of the derivative of the inside. Derivative of x is e to the x is itself. So I have first times the derivative of the second plus the second times the derivative of the first. With these e problems, you're almost always going to have something to take out. So we're going to take out that e. We also have a 2x that we can take out. So 2x, we're left with another 2 here and an x. E to the 4x, I forgot to take out the e. And then we'll also take out the e. You could have done that in one step. In fact, you probably should have, but I forgot. And that's your answer. Right, this is a straightforward quotient rule problem. There is really no derivative of the inside here because these are not chain rule problems on the inside. So we've just got low d high minus high d low over low. So we simplify, and we really aren't supposed to be having fractions over fractions. So we're going to have to common denominator by multiplying this by x over x. So now I have x minus 2 minus x natural log x, because I multiplied, over, and then when you'll notice when we keep flipping these, you're going to notice the pattern that whatever's on this denominator here just kind of gets bumped down. And there are no like terms, so there you go. Right. This one is a quotient rule, except for it's going to have a chain rule here with that 2 on the e. So we've got low d high, so 2e to the 2x, minus high d low, just power rule, over low. And immediately I'm going to see what I can take from the top. I can take out 2 x's and an e to the 2x. So I have x squared e to the 2x. So I'm left with a 2x here. And 3 over x to the 6th. Because when you have parentheses there, you get to multiply. And you'll notice 2 of these x's cancel with 2 of those x's. So that goes away and that becomes a 4. So I got e to the 2x times 2x minus 3 over x to the 4th. Alright, find the equation of the tangent line to the graph of y equals natural log x over 4x when x is 1. Ooh, tangent line. When you see tangent line, step number 1 is going to be y equals mx minus x1 plus y1. x1 is almost always given. It's right there. And in this case, it's 1. y1 is just the y value there. So we're going to plug in x and see what we get. So y equals the natural log of 1 over 4 times 1. Natural log of 1 is 0. Because remember, this is basically saying e to the what is 1. And anything to the 0 is 1. So that's why your answer is that. So 0 over 4, which is just 0. So y equals mx minus 1 plus 0. So we're going to get to leave that part out. Now the most important part for calculus is the m, the slope of the tangent line. So that's where we actually get to do some calculus. Y prime equals low d high. So low d high minus high d low over low low. When you clean it up, these go away, which is kind of nice. So you have 4 minus 4 natural log x over 16x squared, because this 2 belongs to both. We can pull out a 4 to make our lives just a teensy bit easier. And that reduces, so you get 1 minus the natural log of x over 4x squared. And remember, we're trying to evaluate it at 1, so I'm just going to plug in 1. So it'll be 1 minus the natural log of 1, which we know is 0, over 4 times 1 squared, which is 4. So y is 1/4. M is 1/4. And there's your tangent line. All right, on to the 4th page. Which is some old test questions, I believe. So we've got a limit problem. And like I mentioned in the last video, we really aren't doing limits anymore. Or we will at the end of the year, but you're not being tested on limits. So this is actually a secret way of saying, what's the derivative? And the reason we know that is because of the definition of derivative, which is the limit as we approach h is 0 of f of x plus h minus f of x all over h. Okay? So this is the definition of the derivative. Okay? This is technically the way every single derivative could have been taken, except for we learned things like power rule and product rule and all these things, so we don't have to do this limiting process. Okay? This is technically what's happening every single time. So this is the derivative of f of x. Okay? It's also called the difference quotient, all those good things. F of x, f of x, f of x. So really what they're asking here is, what is the derivative of cosine of 3x? And this is in fact a chain rule problem because of the 3x in there. So the derivative is 3 times negative sine of 3x, which is negative 3 sine of 3x. So not a hard derivative. You just need to know that it's a derivative. All right, this one, equation of the normal line. So y equals m, x minus x1 plus y1. Equation of the line, you should just do that immediately. Okay? And they want the normal line, which is fine, at -2. So we're going to do it just like we did before in that previous problem on the last page, except for at the very end we're going to make our slope perpendicular, aka opposite reciprocal. So step 1, we set it up, plug in x1. To figure out y1, we just plug into the original function. So f of, what are we doing? -2 is the cubed root of 3 times -2 minus 2. So that's the cubed root of -6 minus 2, or the cubed root of -8, which is -2. So that goes there, -2. The only thing left is m, so we actually have to find a derivative. So f of x, I'm going to go ahead and rewrite as to the 1/3. And then it's definitely a chain rule problem because of the 3, the 3 in there. So we start with 3 times, and then we just power rule the outside. 1/3 minus 1 is -2/3. And then the cool thing here is the 3's cancel. So I get 1 over the cubed root of 3x minus 2. Okay, so if I just asked you to take the derivative, you would be done. But I want a normal line at -2. So I need to figure out what the slope is at -2. So I get 1 over cubed root of 3 times -2. Oh, this is squared. Almost dropped my 2 there. So I get 1 over cubed root of -8 squared, so 64. And the cubed root of 64 is 4. But again, they want the normal line, so opposite reciprocal. So our answer is going to be -4. And occasionally they'll ask for it in slope-intercept form, so you can just FOIL that 4, or distribute the 4, and combine like terms. Alright, and last problem for this video. At what point is the normal line perpendicular? Okay, so this is kind of an annoying problem because it's kind of like a double negative almost. So it's saying the normal line, which is perpendicular, and they want to know when the perpendicular line is perpendicular. Well, if it's perpendicular to something perpendicular, it has the same slope. So basically, it's saying same slope. Okay. They want to know where this function's normal line is perpendicular, aka tangent, okay, because perpendicular to perpendicular, is the same as this function here. Well, what's the slope of that line? Just y equals mx plus b. So m is going to be 1/4. So long story short, they want to know where this derivative gives you 1/4. So let's start by just taking that derivative, rewriting it as to the 1/2, chain rule, so 3 times 1/2, 3x minus 2 to the -1/2. And rewrite it. Now, that's the derivative. And they're saying, when does it have a slope of 1/4? So instead of plugging in, we're actually setting it equal to. So this. And then we're just going to solve for x. So cross multiply. I'm getting 2 root 3x minus 2 equals 12. Divide by 2. So root 3x minus 2 equals 6. And try to isolate x, so square it. So 3x minus 2 equals 36. Add the 2. 3x equals 38. Divide. That doesn't give me anything pretty, so it's just 38/3. But you'll notice it asks for a point, okay? Not x value, whole point. So I need to go in and get the y value. Luckily for us, we can just plug into the original function. So f of 38/3, and I plug in here. So 3 times 38/3 minus 2 equals root, these 3's cancel, so I get 38 minus 2. Square root of 36 is 6. So that's the point we're looking for. Alright, if you're continuing on to anything on the 5th or 6th page, go ahead and look for part 3 of this video. Make sure you're trying these and don't procrastinate. Get your life together. See ya.